All right, how's it going, everybody? We want to talk today about application problems. Now, application problems is just teacher speak for word problems. Okay, we're going to get into the point where we need to apply what we have learned. All right, we've been dealing with right triangle trigonometry using Pythagorean theorem. We've been using SOHCAHTOA to find missing sides and find missing angles. Now we're going to put that in. And we're going to take that and be able to answer some word problems that deal with it. We communicate with words. We've got to get used to dealing with word problems. Okay. There are a couple things that I need you to take notes over. So at this point, you should have your notes out. You should be putting some things in your notes so that you can eventually be able to draw the correct pictures as you're working through the word problems in the assignment. Okay. The first thing that the first term that I need you all to understand is angle of elevation. Angle of elevation is the angle that's measured from the horizontal upward to an object. So when we are drawing our two lines, we have a horizontal, and then if we're looking upwards to the object, the angle that we are looking is called the angle of elevation. If we're looking upwards, it's called an angle of elevation. If we are looking downwards, that's called an angle of depression. An angle of depression is an angle measured from the horizontal downward to an object. So you have a horizontal, the observer is having to look downward at an object. Okay? And that's called an angle of depression. So angle of depression, we're looking downward. Angle of elevation, we're looking upward. Okay? It's always placed at the observer. All right? Now, great little thing that we're going to use quite frequently on this is if we're getting angle of elevation and angle of depression confused, we're going to use the idea that the angle of depression from one perspective is the same as the angle of elevation from the other perspective. So here we have a control tower. Somebody at the control tower sees an airplane, and at the same instant, somebody in the airplane sees the control tower. The angle of depression for the airplane is the same as the angle of elevation for the control tower. So if this ended up being a 20-degree angle of elevation, because it's looking upward from the horizontal, then this is a 20-degree angle of depression for the pilot. Okay, and that's because these are two horizontal lines. These are parallel lines. So if you remember from your geometry, when you have parallel lines cut by a transversal, then alternate interior angles are congruent. Okay. Bottom line is this. If someone's looking at an angle of depression of 20 degrees, the other perspective is an angle of elevation of 20 degrees. Okay. Here's another example. You know, a dog sees a bird up in a tree. So at that same instant, whatever this angle is that this dog is having to look up from horizontal, the bird is having to look downward from horizontal at the same angle. So again, if this is 45 degrees, then this is also 45 degrees. That's going to help us when we're drawing some of our pictures and making sure that our angle numbers, our angle measures get put in the right spot. Okay? So let's take a look at a couple examples. All right? By the way, there's another picture of just a cat instead of a bird. It's the same thing. All right? The angle of elevation from one location is always congruent to the angle of depression at the other location. Okay? All right, so this is one that students end up having some trouble with when in the assignment. So, spoiler alert. A ship on the ocean surface detects a sunken ship on the ocean floor at an angle of depression of 50 degrees. Let's stop for a second. Does that mean the two ships are right above each other? No, it doesn't. So let's get a picture. One of the most important things we're going to be able to do is draw a picture, okay, or at least label something, all right? I'm going to draw a little ship. Here's my little ship on the ocean surface. Okay, toot toot. All right, it's on the ocean surface. Don't make fun of my drawings. And it detects another ship at the bottom of the ocean. I mean, not directly beneath it, but at an angle of depression of 50 degrees. It has to look downwards at 50 degrees. Now, where we put that 50 degrees is very important. Angle of depression has to be measured from the horizontal. So 50 degrees would go right here. Okay, here's the ocean floor. There's another sunken ship right here. Okay, don't make fun of my drawings. The distance, let's go to this next part. This is another part where people get confused and put numbers in wrong spots. Okay? The distance between the ship on the ocean surface and the sunken ship on the ocean floor is 200 meters. Okay? Where do we put that 200 meters? That's important. Let's go back and read the part again. It says, the distance between what? The distance between the ship on the surface and the sunken ship. Okay? That's not this distance. That's the distance between the ship on the surface and the sunken ship. That's where our 200 is going to go. Okay? If the ocean floor is level in this area, how far above the ocean floor to the nearest meter is the ship on the surface? In other words, what's the depth of the shipwreck? This is the value that we need to go find. All right? If it's level, then that means that this is a right angle. Okay? And now all of a sudden, here is our right triangle. Okay? We like right triangles because we can use Pythagorean theorem if we know two sides, or we can use SOHCAHTOA if we know one side and an angle. Okay? So we've got our trig magic word to deal with. SOHCAHTOA, do you remember what that stands for again? Sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. Okay, this reminds us how to set up our trig ratios. Okay, so let's go label our triangle to see which one of those we're going to use. Again, by putting that right angle right there, we know that across from it is the hypotenuse. Okay, and by having this 50-degree angle in the correct spot as an angle of depression measuring downward, then we know that across from it is the opposite. Did you already decide which trig ratio we're going to use? Opposite, hypotenuse. We're going to use sine. Okay, so we're going to do sine of 50 degrees is equal to opposite d over hypotenuse 200. Okay, that's our setup. Sine is opposite over hypotenuse. Okay, how do I solve that? If I want d by itself, I have to undo division. I undo division with, that's right, multiplication. Multiply both sides by 200, and here's where we go through and calculate. Okay, we can use our TI or we can use Desmos. Again, whether we're using our TI, we have to check the mode. Make sure it's in degree mode, hashtag degree mode. Okay, so we're going to calculate our value by doing 200 sine of 50. 200 sine 50. We're in degree mode, so we know we're correct. Okay, and it says how far is it to the nearest meter up here? It said to the nearest meter. That means the whole number. 153.2. That 0.2 is going to mean I keep this at 153. So the distance is 153 meters. Okay. All right, let's try another one. Oh, no spoilers. All right, a giant redwood tree casts a shadow 532 feet long. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. Okay, so you have an image already. You have a giant redwood tree. Let's go make it red. Redwood. Here's our giant redwood tree, right? Giant redwood tree casts a shadow. Where do we find shadows? Well, we find shadows on the ground. The shadow is 532 feet long. And the only reason it's casting the shadow this way is because the sun had to have been up over here. Okay, happy little sun. All right, it's casting that shadow by shining it this way. It's casting that shadow. Okay, the shadow is not up here in the sky. The shadow is on the ground. All right, but we do know that the tip of the tree corresponds with the end of the shadow, right? And that is where the 25.7 degree angle is going to be, okay? The angle of elevation of the sun, that means if I was standing right here, I would be looking up towards the past the tip of the tree to the sun at a 25.7 degree angle. Okay? We want to find the height of the tree. So we already know that's where the shadow is. Where's the height of the tree? Right here. Okay? This is the distance that we want to go find. Okay? And it's safe to assume that this is a right angle in order to do this. Okay? So again, trig magic word, SOHCAHTOA. All right. Here's the angle of elevation right here, looking upward from the horizontal was 25.7 because that's the elevation of the sun. Okay. This is the adjacent side because this was the hypotenuse. Well, they don't want the hypotenuse. They want how tall is the tree. That's our opposite side. Which trig function do we need to use? We want the opposite. They gave us the adjacent. Opposite and adjacent is tangent. Tangent of 25.7 degrees equals opposite D over 532. And again, if we want D by itself, we have to undo division using multiplication. Okay, let's do Desmos this time instead of our TI. Okay, so remember Desmos, there's a link on my homepage in Canvas. There's a link that you can follow to get to Desmos. Okay, right at the bottom. All right, but again, you go to Desmos, you need to make sure it's in degree mode because every time you reload it, it changes. So make sure it's in degrees, and we need to do 532. Get our trig function, tangent of 25.7. Okay, so there it is. D is equal to, it didn't tell us to go to the nearest foot, so since they used one decimal place in the problem, we'll go ahead and go one decimal place in our answer. So 256.03. If we go to one decimal place, that stays as 256.0. So we say it's 256 feet. Okay. All right, last one. No spoilers. All right. A 40-foot ladder leans against a building. First off, do you have that picture yet? Can you picture that in your mind? Okay, we've got a ladder. It's 40 feet long. Okay, it's leaning up against a building. Okay, all right, there's Mr. Watt on the second floor. That's where my classroom is. Okay, there's a right triangle right here. It's safe to assume that's a right angle. Okay, the base of the ladder is 6 feet from the base of the building. Where do I put the 6 feet? Can't put it here. Got to put it here. Okay. The question is, what angle is formed by the ladder and the building? Where do I put that? I don't put it here. That would be the angle of elevation. What angle is formed by the ladder and the building? That's what we want. Okay, now we want to know an angle. Okay, remember, if you want to find an angle, what are you going to have to use? If you want to find an angle, you have to use an inverse. That's the question I'm going to keep asking, and that's the answer you got to keep giving me. If I want to find an angle, what do I have to use? I have to use an inverse. Okay, but to know which inverse I'm going to use, I've got to go identify my triangle. The ladder is the hypotenuse. Here's the angle. What's the 6 then? What do I call the 6? What part of the triangle do I put that label as? Label it the opposite because it's across from the angle I want. So opposite and hypotenuse, trig magic word. Opposite and hypotenuse is sine. Sine of theta equals opposite 6 over hypotenuse 40. And again, I'm going to ask the question, if I want to find an angle, what am I going to have to use? Going to have to use an inverse. Okay, so now I know if I want to undo sine, if I want that angle there, I have to do sine inverse. Okay, to give me theta left, but if I do it to the left side, I have to do it to the right side. Okay, let's go ahead and use Desmos again to do this. Clear that out, and now I want sine inverse. So function sine inverse of 6 over 40. Okay? And double check real quick, I'm still in degree mode. So this is 8.6 or 8.6 degrees. Okay? Since it's an angle, we have to go and put a degree mark on that. Okay, there's an 8.6 degree angle right there. All right, let me show you with our TI. We do the same thing. This time we have to press, to clear that out, second sine 6 over 40. Okay, we're in degree mode, so we get 8.6. That's 8.6 degrees. Okay, all right, I look forward to seeing you in teams. Come with your questions. Remember, the expectation is that you are taking notes on your own and that you're working out the problems that I'm assigning as quiz problems. It's assigned as a quiz, but it's just your practice. Okay, you need to be showing that work in your spiral or binder, wherever you're keeping your notes. All right, I'll see you on teams.